Hey everyone, welcome back to another video on physics past papers. Today we're going to talk about paper 1 from the February-March 2024. Just to show you some resources that we have developed, which are all available on Patreon. For AS, we have frequently examined questions, which are basically paper 2 questions that come up again and again. Then we have definitions and formulae. This is the document which you might see us using in the video. As you can see, this is the reasonable estimates one. We have important derivations that come up, including for example, the uh, resistors in parallel, resistors in series. Then for A2, we also have frequently examined questions. And for this one, we have structured it slightly differently. Syllabus contents on the left, question and answer on the right, and years on the rightmost. As you will see, there will be some questions which are repeated again and again. Graphs for A2 are very important. We all struggle with the difference between potential and field graphs. Then we have A2 definitions and formulae, which is very similar to the AS1. Derivations, we know we get the gravitational field derivations quite a lot. And last but not the least, we have paper 5 planning question, checklist, and some worked examples. So they're all available on Patreon. You should check it out before you have the exam. All right, so let's start with the paper. Which row shows a physical quantity and its base unit in the SI system? So physical quantity and its base unit in the SI system. So current is the base quantity and its base unit is amperes. So I think that's it over here. A car of mass 850 kg is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. One force has a magnitude 1200 Newton. The other force has 1600 Newton. What is the magnitude of the acceleration of the car? So basically what we would do, we would employ the Newton's second law. So acceleration would be sum of forces. This would be 1600 minus 1200, which would just simply mean, obviously we know that this is going to be the applied force of the engine, but this would just simply mean that we are getting a deceleration instead. So divided by the mass, 850. So this would be 400 divided by 850 kg. Oh, sorry, no. You get 0.47, so this is A. Okay. An object of mass m is suspended by a spring from a fixed point. The spring has constant k. The object is set into vertical oscillations of period t, which the unit for that is second, s. Which equation for t is homogeneous with respect to its base units? So this means that the right-hand side should also end up being seconds. So the spring constant, we know that spring constant is related by F is equal to kx, and k would be force over extension. So its units are Newton per meter. In case you don't know, you can reuse these formulae for that. So basically what we need is a second. 2 pi themselves, they have no unit. So we have seconds, and on the other side we have Newton per meter, and with respect to its base unit. So Newton, we can force has units, base units, kg meters per second squared, mass times by acceleration. So if k has kg meters per second squared divided by x, which is also Newton per meter, so this would be per meter, so this and this would just simply cancel out. So this would be just simply k. This would be just simply for second square. So meter over K, that's not going to be. Okay, so one thing you need to see over here, we have second over here with the power 1. And on the right side, at least the K is -2. So first off, we need to take the reciprocal of K and we need to take the square root. That's the only way we are actually getting the S power +1. So this would be this one. Just to be sure, M has mass kg and K has mass kg second squared. Once you take the square root, you get this. This converts into -1 s raised to power, sorry, no, 1 over -1. And this is basically just s. So this would be d. An object of fixed mass is initially at rest at point P, the object that moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? So, if the acceleration is uniform, the resultant force acting on it will also be uniform. It increases uniformly with respect to time? No, it is constant but not zero. This is correct. If acceleration is constant, force will be constant. A projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of 13 meters per second. What is the vertical component of the projectile when it is launched? So the angle is 25 degrees and the horizontal component of this is 13. So we need to find the vertical one. So this is very straightforward. We will use tan 25, basically the right angle property, tan 25 degrees. Vertical one, let's call it Vy over 13. So this would be 13 tan 25. 13 tan 25, 6.06. So basically this would be B. A ball is released from rest at position X at time t is equal to 0. So that means if it is released from rest, that means u is equal to 0. At time 1 seconds, it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at 1.5 seconds. What is the total displacement of the ball from its original position at 1.5? So basically total displacement would be the sum of this positive area and the negative area. So half times by 1 times by 10 minus half times by 5 times by 0.5. So this would be 5 minus 0.5 times by 0.5 times by 5, which is 1.25. So this is going to be 3.75. 3.75 net displacement basically. What is the definition of acceleration? So change in velocity over change in time, or rate of change of velocity. Per unit time would add an extra component of time over here. Had they said with respect to time, that would have been okay. So change in velocity per unit time. Two balls, P and Q of equal mass, move along in a straight line directly towards each other, shown. Ball P has velocity 1.3 meters per second to the right. Ball Q has velocity 0.5 meters per second to the left. P and Q collide with each other. The collision is perfectly elastic and the total momentum is conserved. Which diagram correctly shows the motion of P and Q after the collision? Okay, so if it is perfectly elastic, we have this relative velocity of approach equals to negative of relative velocity of separation. So although the magnitudes are equal, but they will be in opposite directions. So as you can see, this would be d, but just to show you that this is going to be the correct. So if we take this direction to be positive, you will have up minus, and since this is in opposite directions, we will write it in a second. Vp minus Vq, relative velocity between the two. So this is 1.3 minus 0.5. This is going to be 1.3 is 1.8. And this will turn out to be Vq minus Vp. Now notice Vq minus Vp is the relative velocity of its separation, but this would mean that this is in the opposite direction. So the sum of those would be same but in opposite direction. So as you can see, 0.5 is going in the opposite direction, 1.3 going in the other direction. So if you do Vq minus Vp or even Vp minus Vq, you will get 1.8 as before. So this thing, Vq minus Vp, Vq is 1.3 and 0.5 is going in the other direction, so 0.5. As you can see, this will end up 1.8. So D is the correct answer. A basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.9 meters. So basically hits the ball vertically downwards with a speed of 2.4 meters per second. So this is the ball. Okay. Air resistance is negligible. What is the speed of the ball as it hits the ground? So this would be 2as v squared minus u squared. So v squared is what we need to figure out. So 2as plus u squared. Since it is like going in just simple one direction, you can just simply use 9.81 without having the minus sign. 0.9 plus u squared is 2.4 squared. Remember, this is going to give us v squared, so we have to use the square root. 2 times by 9.81 times by 0.9 plus 2.4 squared. So this is 4.839. So this is going to be B. A ball falls through a liquid at constant speed. It is acted upon by three forces: upthrust, drag force, and its weight. Okay, so it's falling through the liquid. We know weight acts downwards, and it's falling through the liquid, so obviously that means it's falling downwards. Upthrust is this way, and the drag force will also be acting in the opposite direction of motion. The liquid has uniform density. Okay. Which statement is correct? The drag force increases with increasing depth. No. The drag force only increases with speed, but since it is moving constantly, drag force would be constant. And so will the upthrust be. If it's falling through the liquid, inside the liquid, the drag force is constant also. The drag force is equal to the sum of upthrust and the weight. No, the upthrust is constant with increasing depth. So upthrust, we also know upthrust is rho GV if it's falling through the liquid. So volume of the wherever the object is, ball, is the volume displaced. So entire body is will be counted as V. Some small solid cubes each have mass 1 kg and sides of length 5 centimeter. These small cubes are stacked together to form a large solid cube with sides of length 2 meters. What is the weight of the large cube? Okay, so basically we have 5 centimeter each, and they are all stacked together to form 2 meter cube. So first off, we need to know how many cubes are in one side. So basically 2 200 divided by 5. So this is going to be 40. 40 this side, 40 this side. So if now hold on one second. So if this layer is the 40th, or if this layer is the first, the next would be 39. So one layer is to 40, like 1, 2, 3, 4, 5 up till 40. And this is the counted as the first layer, so first row. So the next row will start from a 2, 3, and so on up till 40. So you have to be very careful with that. So how many do we have? 40 times by 40, 160. That part is not changing. However, just to see what is actually going on, you will actually have 40 cross 40 cube over here. So you have 160. So 160 kgs of this, and then times by 9.81 newtons per kg for this one. So 160 times by 9. Oh, sorry, no. So 160 times by 9.81. So this is 1569. Oh, I forgot the third dimension. I forgot the third dimension. So 40 times by 40 times by 40. So 1600 times by 40. So this is going to be 630. 630. 627, 840. Or if you go in the standard form, so this is 1, 2, 3, 4, 5, 6. So 0.627 meganewtons. This would be the correct answer. A borehole of depth 2000 meters contains both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascals. The density of the oil is this, and the density of the water is this. What is the depth x of oil? So basically we need to figure out what is the volume of oil, in short, basically. So we have the depth, and we have the depth of, so this would be 2000 minus x. Right, okay. And this is at the bottom. So the force exerted by both of them is the weight of the oil plus the weight of water. We don't need to do write the full thing. Divided by area. Area is the same for both of them. Cross-sectional area, basically. This thing, borehole. So rho g h for this plus rho g h for this. So this is oil, this is oil, this is water, this is water. G is the same for both of them. Okay. Density of oil is 830 times by 9.81 times by x plus 1000 times by 9.81 times by 2000 minus x. So actually, wait, let me write over here. So this is 17.5 mega 830 times by 9.81 times by x plus 1000 times by 9.81 times by 2000 minus x. Okay, so we'll solve it one by one. So 830 times by 9.81, so this is 8142.3 x plus you have 1000 times by 981, 9810, and times by 2000. So this is, I don't want to use the full number. So this is going to be 1.962 10 raised to power 7 minus 9810x. And this is equal to 17.5 megapascal. So we need to collect the x terms together. So this will go on this side. So 9810x minus 8142.3x equals to 1.962 10 raised to power 7 minus 17.5 10 raised to power 6. This would be basically 19.62 10 raised to power 6 minus that. So we have 19.62 minus 17.5 divided by 9810 minus 8142.3 times by 10 raised to power 6. So this is 1271 10 raised to power 3. So this is roughly 1270. Yeah, this is the only option. So x is coming out to be 1271.2. Right, okay, moving on. A rod is pivoted at one end. So basically, rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0 degrees. The weight of the rod causes a moment about the pivot. Moment m about the pivot. Oh, no, sorry, no. The weight is w, but the rod is then rotated in a vertical plane so that the angle theta of the rod increases from 0 degrees to 180 degrees. Okay. Which graph shows the variation of m with theta? So, as we go in this angle, the weight actually becomes this, but we need this angle, right? We need this angle, so this would become mg cos of theta. This is our theta. So whatever the distance was, whatever the original force was, whatever this distance is, it doesn't say if it was a uniform rod or something. So if originally m was mgd, now it's going to be mg cos theta d. So this is now, new moment is m cos of theta. And at 90 degrees, the weight will actually be passing through the point of pivot. So at that point, the moment will be 0. So the cosine graph is actually this one. But as you go over here, the moment is changing. How? Because up until it's on the right hand side, it's clockwise moment. But as it goes on this side, it's anti-clockwise moment. So the direction of movement is also changing, as evidenced by the cos theta thing. So just to make sure that we're not missing out anything, yeah, so basically cos theta graph, this is the cos theta graph. All right. A hinged trapdoor is held closely in the horizontal position by a cable. Three forces act on the trapdoor: the weight W of the door, the tension T in the cable, and the force H at the hinge. Which list gives the three forces in increasing order of magnitude? In increasing order of magnitude. Okay. So, increasing order of magnitude. So, right, okay. So wait, so if you see the moment over here, so this is going to be, let's say this is theta over here, this is 3 sine theta, and this is just simply W. So T sine theta is enough to balance out the moment with W. So if you take the moment about the hinge, this won't count because it's passing through the moment. So moment, sum of moments, actually we can do moments, T sine theta times by, let's call this X distance, and this is W, Y, let's call this Y. We know Y is greater than X. So what would that mean for W and X? So basically that would mean that for T, for T, if you just think about this, so W Y over X divided by sine theta. So Y over X, as you can see, if you figure this out, this becomes Y over X is greater than 1. So it's greater than 1. So this means, and sine theta is always between 0 and 1. So what does it actually tell you? That tension itself is very high. Tension itself, but due to the T sine theta, so T sine theta, if you just simply look at the sine theta, if you increase the sine theta, it goes to a maximum value at 90 degrees. But as we can see, it's less than 90 degrees, so its value going to be less than that. So tension would be highest. Tension is the highest. Weight is, tension is the highest. Tension is the highest. H would be in between them actually. H would be in between them. So H in between, and tension higher than weight. So tension is always higher than weight. So if you think about this, tension higher than weight, this would cancel out. This would cancel out. So you will have C and D to check. H would be, H can't be the greatest one. Okay, because H is balancing this in the direction of forces basically. So the moment is balanced out by T and W, but H is actually giving the resultant force, or the force in the other direction basically. So this would be the, I think this would be the correct answer, because H can't be greatest. Okay, what is the definition of the force? Okay, so if, for example, if you get stuck over here, so we can actually figure this one out. So we don't actually know what the angle this is. Let's call it alpha. So this is T sine theta, and this is weight, although they are not acting at the same point, but for a beam that is horizontal, we can, let's say that. And this is H. Let's give it alpha over here. So as you can see this over here, this is absolutely clear over here that T sine theta is able to handle the H cos alpha plus weight. So T sine theta, we already said that it's lower than T itself. So T would be the highest. Cos theta graph goes like this. So higher the cos value, higher the angle value, lower the cosine. So it's all h cos theta, h cos alpha already means it's lower than the h value. So that means it's in between. It's in between. And weight, there is no weight, there's no angle component, so weight would be the lowest one. What is the definition of the force? Mass times by acceleration. That would make sense, but actually definition of force is rate of change of momentum. Product of mass times by acceleration becomes the special case of rate of change of momentum. A boat moves at a constant velocity v through still water. The constant drag force F acts on the boat. What is the power used by the boat to move forward? Okay, so if you have a problem understanding this, you have a constant drag force F, and you have some rowing force, whatever this is, let's call it P, let's call that P power force over here. D force, driving force, let's say. So D minus F, which is equals to MA, that is equal to 0. That means D is equal to F at the very least. No, not at the very least. It is D is equal to, because it's moving at constant velocity. The power used by the boat is actually coming from D, and since it is opposing the drag force, this is going to be Fv. So if you are concerned, just simply multiply V on both sides times by V. So this is going to be dV is equal to Fv, which basically means power used by the boat is basically power lost against the drag force. The diagram shows four forces acting on a circular disk. Each force has magnitude F. The two of the forces act vertically and two other forces act horizontally. All forces act in the same plane as the disk. No other forces act on the disk. The disk has diameter d. Which statement is correct? The disk is in equilibrium because the resultant force is 0. No. The combined effect of that is actually double the couple of each couple forces. So basically this is going to be 2F FD plus FD. So basically it's not in equilibrium. So A and C are cancelled right away. Resultant torque is 2FD. That's the correct answer. A ball is projected into the air from the horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energies EQ, ER, ES, ET. Respectively, the heights above the ground of these 4 points are shown. Which difference in kinetic energies is the smallest? Okay, so you have to remember that it's into the air. It's into the air. So basically there is going to be a resistance. So the change in, the net change in potential energy is going to be net change in EK plus, you can say, the work lost against the air resistance. Air resistance is negligible. Sorry, my bad. I didn't see this. So this would go away. This would go away. So now that would mean that the kinetic energy is half mv squared. 1.8 would have the same kinetic energy over here at 1.8. 1.3 would have the same 1.3 over here. So basically the same points would have the same kinetic energy. So let me draw lines to illustrate the point. So at this, the kinetic energy is only due to the horizontal kinetic energy or horizontal velocity. So actually we can do that. Then you have 1.6 and 1.5, which are the closest in height. So the change in height basically is the lowest. Change in height equals to change in kinetic energy, so that is the lowest. So these are points Q and S, Q and S. The battery of a small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours to charge the battery. The efficiency of charging process is 80%. What is the total energy stored in the battery? Okay, so 10 times by 2, so basically energy is equal to PT. So this is the input, 2 hours, and we need to convert it into seconds. 1 hour is equal to 3600, and it's 80%, so 0.8. So 10 times by 0.8 is 8, times by 3600 times by 2. This is 5.76, 10 raised to power 4. So 10 raised to power 4 is this one. Initially, stationary firework explodes and splits into 2 fragments that move horizontally in opposite directions. So this is an example of conservation of momentum. Total kinetic energy transferred to the fragments by the explosion is E. One fragment has mass m, the other has mass 2m. What is the speed of the fragment mass m immediately after the explosion? Okay, so remember this. If this is initially, so momentum before, sorry, no. So sum of mv before, sum of mv after. So before is 0, they are going to be going in opposite direction, so momenta are going to be opposite. So m equals to v1 minus 2m v2. So mv1 equals to 2 mv2. Notice that m and m can get cancelled out. So v1 is equal to v twice the speed of v2. What is the speed of the fragment mass m immediately after the explosion? So total kinetic energy. Okay, so total kinetic energy transferred to the fragments by the explosion. Okay, so total kinetic energy of these, half mv1 squared equals to half 2m, and v2 is half of v1 squared, and this is equal to E. Now we need to simplify this a little bit. So this is half mv1 squared, and you notice that half cancels, so half mv1 squared also, half m this is going to be 1 over 4 m1 v squared equals to E. So this is times by 2 times by 2, so this is going to be 2m v1 squared plus mv1 squared over 4 equals to E. E is going to be so like the left hand side simplifies to 3mv1 squared over 4 equals to E. So v1 squared would be 4e over 3m, and v1 whole under root would be 4e over 3m. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy P. Spring constant is K, so half kx squared. What is the relationship correct for the spring? EP is proportional to F. That is correct because this is half Fx. Well, let's see for a minute what that means. EP proportional to X, EP proportional to K, EP proportional to X squared, EP proportional to X squared. I think D should be the correct one. D is the correct one because K is a constant, half is a constant, X is the only variable. But over here, F and X are both variable at the same time. So we can't actually use that because if you just consider EP equals to half Fx, in this case, only half is the constant. Fx is the constant. Fx is the variable part itself. So we have to keep one of them constant. So in this case, half and k are constant. So yes, the proportionality will stand. The force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? So force extension graph, limit of proportionality is where the straight line ends. The point at which the wire breaks. No, the point beyond which Hooke's law is not obeyed. Hooke's law basically is this basically force directly proportional to x. So that would be the correct answer. Proportionality. This is the proportionality that we are talking about. A spring has a spring constant of 6 Newton per centimeter. It is joined to another spring whose spring constant is 4 Newton per centimeter. The load of 80 Newton is suspended from this composite spring. What is the extension of this composite spring? Okay, so although it's not in the syllabus, but when you arrange them in series, I think we have this in, I forgot, but I think it's in the derivations. It's in the derivations, maybe. Oh, yeah. Springs in series, yes. So when they are in series, the net spring constant is going to be the sum of reciprocals of individual ones. And when they're connected in parallel, it's going to be the sum of the spring constants. So going back, so 1 over k effective would be 1 over 6 plus 1 over 4. So this is going to be 1 divided by 6 plus 1 divided by 4. This is 5 over 12. So the answer would be 12 over 5 Newton per centimeter. Now, what we have over here, extension, we need to figure out. So extension is going to be F over the K, 80 divided by 12 times by 5. So 80 divided by 12 times by 5, that is 33 centimeter. Since we did not change the units over here, so this is going to be that case. The range of frequencies of sound waves emitted by blue whale is 10 Hz to 40 Hz. Speed of the sound in seawater is approximately 1.5 kilometers per second. What is the approximate range of wavelengths of sound waves emitted by blue whales? So notice the options have millimeters, centimeters, meters, meters. So we need to convert these into meters. So this is 15. Kilometers is 1,000. So this is going to be 1,500 meters per second. So wavelength is going to be V over F. So 1,500 divided by 40 Hertz and 1,500 divided by 10 Hertz. So this is where the wavelength would lie in meters. So 1,500 divided by 40. Wait a second. This is going to be 37.5 meters and basically 150. Since we converted the speed into meters, so this is it. No, this is meters. No, this would be correct. A sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope. Frequency of the wave is 2.5 kilohertz. What is the setting on the time base of the CRO? Okay, all right, so let's see. So If frequency is 2500, just simply 2.5 times by 1000, so 123 hertz. So the time period would be 1 over 2500. So 1 divided by 2500, this is going to be 4 milliseconds, basically. No. Wait a second, I forgot. 4, 10 raised to the power minus 4 seconds. 10 raised to the power minus 4 plus 10, and then 4 divided by 10. Okay, so 0.4 milliseconds. Sorry, yes. So 0.4 milliseconds is the time period. And we have 1, 2, 3, 4. So I think this is going to be 0.1 milliseconds per centimeter. So milliseconds. A source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at the observer's position with waves emitted by the source of the sound. What is detected by the observer? So we know that due to the Doppler effect, the observed frequency would be higher than the original frequency or the source frequency. So wavelength would be changed also. Frequency is also changed. So decreased wavelength. So if frequency is increased, wavelength would be decreased. So C would be correct answer. Which type of waves cannot be polarized? So longitudinal waves cannot be polarized. So this is not longitudinal, this is longitudinal. A beam of light with power P has a cross-section area A. The amplitude of the light waves in the beam is X. Okay, the beam of the light is then changed to 1 with the same frequency but with an increased amplitude of 4x and a cross-section area reduced to A over 3. What is the power of the new beam? Okay, so we know intensity is power over area. So before the area, and intensity is also proportional to amplitude squared. So I'm going to write this as x squared. So what is the power on the new beam? Okay, so we can actually do this. So P1 over A1 over P2 over A2 equals to x1 to x2 squared. We can actually swap these out also. That doesn't really matter. So these are the original ones, and the numerator ones are the ones that we are actually trying to find. So now the amplitude has been increased to 4x and the cross-section area is reduced to A over 3. Okay, so P1 A1 over P no, area is now A over 3. A over 3, this is divided by A over 3. Oh, come on. Divided by A over 3. And what do we have over here? This is divided by A. And x is now, amplitude has been increased to 4x. So this is going to be 16x squared over x. So what do we have over here? So x squared cancels out with x squared. A will cancel out with A. So we are left with P1. And so this is going to be 3P1 basically. So as you can see, this is like P 1 divided by a over 3. So this is going to be like 3p over a. So 3p1 equals to 16p. So P1 would be 16 divided by 3p. So this is 5 point something. 16 divided by 3, 5.3. Ah, yes, thank God. Right, okay. So two loudspeakers are connected to the same signal generator. The signal generator provides a single frequency. The loudspeakers face each other so that a stationary sound wave is set up in the region between the loudspeakers. Okay, microphone is connected to a cathode ray oscilloscope and positioned between the two loudspeakers. The microphone is moved along a line joining the two loudspeakers. The signal on the CRO shows 5 maximum amplitudes as the microphone moves. The microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives fifth maximum. What is the wavelength of the sound wave? Okay, so remember this. So you have antinode, node, antinode, node, 5 maximum, right? So 1, 2, antinode, node, third, fourth, 1, 2, 3, fourth, and fifth. So the distance covered is 2 meters. We know that antinode to node, or the node to node distance, is basically lambda by 2. So basically this is one complete wavelength and this is one complete wavelength. So wavelength is basically just 1. Alright. Two wave sources emit coherent waves. Which condition must be correct for coherent waves? So coherent waves, just to show you, although we know the answer pretty well, coherent waves have a constant phase relationship. So waves, yeah, okay. Coherent, where did that go? Okay, constant phase relationship. They emit waves with a constant phase relationship. So constant phase relationship, this one would be correct. A student sets up an experiment to investigate double slit interference. Student uses light of a single wavelength from a laser to illuminate a double slit so that a pattern of interference fringes is observed on the screen. The student finds that the fringes are very close together. What could the student decrease in order to increase the separation of the fringes on the screen? So remember, you have lambda is equal to ax over d. So x is basically lambda d over a. So we need to increase the fringe separation to increase the separation of fringes. So basically you can decrease the a, which is the separation of the slits themselves. Yes, because the question was decrease. It's not asking for a specific change. Sorry, it's not asking for a increase or decrease. It's just simply asking for decrease. What are the definitions of potential difference and electromotive force in terms of energy transfer and charge Q? They're both the same in terms of like energy transfer and charge Q. They're both the same, but this is the energy transferred from electrical to other forms, and this is the from other forms to electrical. The diagram shows a network consisting of 3 resistors. What is the combined resistance of the network between terminal X and terminal Y? So we start by finding out what's the combined resistance of these two. So 1.2 plus 1.4 over 7, sorry, 1 over 4.7. So this is going to be 1 divided by 1.2 plus 1 divided, 1 divided by 4.7. Okay, so this is 1.2 Okay, so basically what we needed was 1 divided by this. So this is 0.95. So this in thing is 0.9559 and then plus 2.2. So this is going to be plus 2.2 kilo ohms. So this is going to be 3.155. So this is going to be C. Okay. A resistor dissipates 25 watt of power when there is a potential difference of 4 volts across it. What is the resistance of the resistor? So P is going to be V square over R. So resistance is V squared over P. So V is 4 squared and P is 25. So 16 over 25. So 0.64 ohms. Right, okay. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of the variable resistor is decreased. What happens to the potential difference V across the variable resistor and the current I in the variable resistor? So, one thing, okay, so you have this parallel combination. So remember that when you decrease the resistance, so the net resistance would decrease. So because you have 1 over R1, 1 over R2 for these two, the effective resistance becomes R1 R2 over R1 plus R2. The combined resistance of these two would decrease, which means that the combined resistance of the circuit would also decrease. So if the combined resistance of circuit decreases, then that means current increases. So first off, let's cancel out those. So current decreases. So, oh no, sorry, C decreases. Okay. So now we need to see whether B or D are the correct one. So if the current is increasing, that means the V is equal to IR, so EMF minus the lost volts. This is the terminal potential difference. Actually, this is just simply just equal to V. So if the current is increasing, the lost volts would increase. So the V would decrease. B is the correct answer. And a radioactive source produces a beam of alpha particles in a vacuum. The average current caused by the alpha particles in the beam is this. A beam is incident on a metal target. What is the average number of alpha particles hitting a metal target in a time of 3 seconds? Okay, so remember one thing over here. So the average current caused by alpha particles, so remember, this is, if you do the Q is equal to NE thing, in alpha, you have 2e charge per particle. Unlike the electron, it's positive 2e. So basically what you would be doing, it's actually not going to be NE, it's going to be 2e and divided by t divided by t. So in 1 second, it is 1.5 10 raised to the power minus 9. That means in 1 second. So this is going to be n times by 2 times by 1.6 10 raised to the power minus 19. So this is in 1 second. And once we have in 1 second, we can do that for 3 seconds. So 1.5, wait, first second. First 1.5, 10 raised to power minus 9 divided by 2, 1.6, 10 raised to power minus 19, and then multiplied by 3. So 1.5 divided by 2 divided by 1.6 times by 3, 10 raised to power minus 9 plus 19, 3.6, no, wait a second, in a time of 3 seconds. 1.5 divided by 2 divided by 1.6. So, right, yeah, 1.4 10 raised to power 10, 1.4 10 raised to power 10. Right, okay. The charge carriers in a metal wire are free electrons. Which statement about the charge of each free electron is correct? The magnitude of the charge increases with potential difference across the wire. No. The magnitude of the charge is 0 unless there is a potential difference. Okay, no. So basically what happens is that the current flowing through it is dependent on the potential difference. Not the charge, not the sign of the charge, not the magnitude of the charge. So this is 0, this is 0. The sign and the magnitude of the charge do not depend on the potential difference across the wire. This is correct, but let's see. Sign of the charge depends on the potential difference. Nope. Which flavors of a quark have charge plus 2 over 3? So U, C, T, up, charm, top have plus 2 over 3. Just to show you that we have thought about it, we have a table at the end of this formula and definitions booklet. This one. So charge 2 over 3 up, charge 2 over 3 charm, charge 2 over 3 for top. So up, charm, top. So charm and top, and down, strange, bottom have minus 1/3. So this is something you will have to remember. So only options do we have are charm and top. So A. An unstable nucleus of an element decays by emitting an alpha particle or a beta particle to become a nucleus of a different element. This nucleus is also unstable and emits an alpha particle or a beta negative particle. The process then continues until an isotope of the original element is produced. What is the minimum possible number of these particles emitted? So this would be, okay, so remember this. If, for example, you have X, A, Z, we know that if it decays by alpha, this number decays by 4 and Z decays by 2. We are already familiar with this. If it decays by beta negative, in that case, proton number increases by 1 because in beta negative, a neutron decays and A remains as it is. And this is the beta negative, 0. So if we want to get an isotope back, then that means the minimum amount that we need is beta 2 and at least 1 of alpha. Because if we go 2 of beta, the proton number would increase by 2, and the alpha, 1 alpha, would reduce the proton number by 2. So the net effect would be 0. The net effect would be Z back again. So 3 are the minimum choices. Okay, a nucleus of carbon-10, C10-6, decays by beta emission to form a nucleus of boron 10-10-5. Okay, so remember this is where the proton number decays, a proton number decreases. This is beta plus. For this decay process, what is it change to a nucleon and what is it change to in the quark composition of the nucleon? Okay, so nucleon number remains the same, so change to nucleon. Okay, so uh, we saw this over here that in beta negative, where did the beta negative go? Actually, we didn't see that. Okay, never mind. In beta negative, a neutron decays into a proton and an electron or a beta negative particle and an anti-neutrino. But in beta positive, a proton decays into a neutron and a positron and an electron neutrino. So in this case, it's a proton to a neutron. That means these two cancel out. And since it's a proton, which is up, up, down, converting into a neutron, up, down, down. So one up converts to down. So B is the right answer. All right, so I hope I was able to make this fun and informative and easy to follow. If you have any questions, do reach out in the comments. If you feel that I made a mistake somewhere, also reach out in the comments. And like this video, subscribe to our channel, and turn on the notifications for our channel so you can be updated whenever a new video is uploaded. All right, so see you in the next video. Bye-bye.